Hey, do you realise what's happened? We've got these things called logarithms. And why don't we investigate them a little bit further? And what we're going to do in this presentation is look at the rules of logarithms. Just remembering this little dude in here now. Hang on, there he is. Logs are powers, smiley face. And this is what this whole screen's about. Writing numbers as powers of 10. Don't forget the rational powers are half there, square roots and combinations. Here, 10 to the 1, and root 10 is 10 to the 0.5. Overall power is 10 to the 1.5. Down here, what about the negative powers? Don't forget them. So the fifth root is 1/5, but 1 over that is the negative power, 10 to the neg 1/5, or 10 to the neg 0.2. Well, do you remember all that stuff? Let's look at what's going on once we go into logland. And here you are. Logs of powers, just remember over here, it's on every screen. I'm trying to get that into your head. Logarithm in base 10, what would that mean? The logarithm of a positive number in base 10 is its power of 10. Later on we're going to look at why you can't find the log of a negative number. It's a power of 10 here that we're looking at for the logarithm. So log to the base 10 is 1,000, of 1,000 is 3. The power you raise 10 to get 1,000. Or you can leave out the 10. Log in mathland just means the log to the base 10. Understood? So you can write that. So let's have a look at what happens when we try to work with logarithms outside of just finding the solution to an exponential equation. Just remember, logs are powers. So another way of writing the fact that a log is a power is if you want to get the number a, you'll raise 10 to log a, won't you? Because what's the log a? The power you need to raise 10 to get a. Logs are powers. So this means a power of 10 necessary, needed to get a. That's what log a means. So if you raise 10 to that required power, you should get a. Or what's another way of looking at that definition? That the log of a number is the power of the base. If you're finding the log of a number here, here's the number, 10 to the x, you're trying to find a power of 10. Well, hang on, it's already written as a power of 10. So the answer is x, because the log of a number is the power you raise the base to. Okay, and here we've already got the number written as a power of the base, so the log is just that power. Remember, logs are powers. So come on down, let's start doing some stuff. So without using a calculator, find the log of 100 or the log of the fourth root of 10. Log of 100, we'll try to write 100 as a power of 10. And the answer is 2. Okay, log of the fourth root of 10. Write the fourth root of 10 as a power of 10, 10 to the 1/4. The log is just the power. Okay, or you could go to the calculator. But what we're trying to do here is to get up close and personal with logs and to try and work out problems without the calculator, with just a good understanding of logs. Okay, come down now and let's have a look at some exercises. Here's the first one. Just remember, logs are powers. So without using a calculator, find the log of 10,000. So the idea is to find the power of 10 needed to get 10,000, and so on right the way through here. So have a go, and you can check your use with a calculator. Not so important here. Okay, I want you to use the definition, and remember, logs are powers. So pause the presentation, have a go, particularly question one, should do all of those. Let's have a look at the answers now. There are the answers. Okay, hope you got some there, without a calculator. All right, let's go on and just build this up a bit. What can you do now? Okay, remember, logs are powers, and so find the log of 10 to the x times 10. Well, we better get a single power for this combo here, and this is 10 to the x times 10 to the 1. Remember the power rules, they're going to be important in logs, aren't they? Why? Because logs are powers. So 10 to the x plus 1, the log of that is x plus 1, because the log is the necessary power of 10 to get the number. Okay, if the number's already written as a power of 10, then that's easy street. Okay, so find the following logarithms. The log of 10 to the a. What power of 10 do you use to get 10 to the a? Duh, I think it's already written there, mate. Okay, Well, have a go and see what you think, and I'll show you the answers now. There we have them. I hope you got those. Don't be frightened to work in pronumeral land, okay? Just remember your basic ideas and apply them. Pronumerals stand for numbers. Okay, so here we go. Let's have a look at some more things that we can do. Remember, here's to do it again. Logs of powers. Use your calculator to write the following in the form 10 to the x, where x is correct to 4 decimal places, because these are not straight powers of 10, and we used logarithms. That's how we discovered logarithms, wasn't it? In trying to solve exponential equations, we couldn't write them as easy powers of a base. So what is 8 as a power of 10? Well, remember, logs are powers, so you'll have to look up the log of 8 and make it the power of 10. This is going backwards now. So have a look at the calculator entry there. So 800, what power of 10 do you need to get 800? Well, the definition of the log is the power of 10 you need to get the number. So the power of 10 to get 800 is the log of 800. Do you get the idea? Backwards and forwards between logs of powers, and the power is the log, backwards and forwards. So you might have a go at some of these, not so important here, but have a go at maybe every other part, alternate parts. And I'll show you the answer now. There we have it. All powers of 10 now. All right, so check out your thinking. Logs of powers. Let's go down and have a look at the next example here. I'll just bring up some little problems underneath. So screen clippings here from Hayes and Harris Publications. So it'd be good to have that book there and have a look at it. Okay, just remembering, logs of powers. Use your calculator to find the log of 2 and the log of 20. Okay, so just enter it on the calculator, 0.3010, 1.3010. Log of 20. Explain why the log of 20 is the log of 2 plus 1. Did you see it? There's the log of 2, and now we put a 1 in front. Well, let's look at 20. 20 is 2 by 10. Okay, so that's the log of 10 to the 0.3010 by 10 to the 1. Okay, so then with the power rules, we add the exponents or powers or indices, and so we can write it as that, and the log of a number written as a power of 10 is just a power. Remember, logs are powers. So that's the idea now, and just getting your head around the idea that the log of a number is a power of 10, and if you're timesing things together, like we were up there, you'll add their powers, won't you? We'll come to that a bit later on now. I want you to have a go at these, and I'll show you the answers. There are the little answers there. Okay, let's move on. It's getting interesting, isn't it? Maybe a bit complicated, but interesting stuff. So find x if the log of x is 3 and the log of x is approximately -0.271. The log, remember over here, little dude, the log is the power of 10. So if the log of x is 3, x is 10 to the 3. The 3 is the power of the base, so it's 1,000. Okay, x is 10 to the log of x. I don't think you need that, except it might actually confuse you. So if the log of x here is -0.271, then -0.271 is a power. As soon as you say the log is equal to something, then that means you know the power of the base, and you can track back and get the number. Okay, have a go at these. Remember, over here, little dude, the log, if you're told something has a log equal to something, then that is the power of the base. All right, pause it. You should do all of these and see what you come up with. I'll show you the answers now. Okay, so there they are. Just check them. I hope you're getting a few right. Check with your teacher and your classmates. Let's go on and see if we can summarise what we've been doing. Okay, there's 3 important laws of logarithms. I think you're starting to see the idea. If you add up logs, remember, hang on over here, this little dude, logs are powers. If you're adding up logs, you would be finding the log of a product. Because when do you add powers? When you multiply 2 things together. So basically the log rules are the power rules. And you're just working with these dudes. So add up logs means you're finding the log of a product. Subtract logs. Oh, why would you subtract powers? You'd be dividing them. So that would be a to the m on a to the n, and you would be subtracting the powers. Remember, in logland, we're only working with the powers. We're detaching them, if you like, from the exponential expression. Remember here, you can't divide by 0. And then if you multiply the log, remember, logs are powers over here. If you multiply the log by a number, why would you do that? Well, that's when you raise a number to a power, isn't it? Remember that? When do you multiply powers together? Over here, it's when you have a power raised to a power. All right, so there are some rules. Let's come down and look at some more formal proofs of those. I think you can see it, but let's formally prove it. If you've got a number a times a number b, you can write number a as 10 to the log of a and b as 10 to the log of b. You would then, what would you do? You would add the powers, okay, because that's a power rule, and therefore you would say AB is 10 to the log of A plus the log of B, or 10 log AB. Okay, you'd be adding the powers there. Okay, adding the powers, log A plus log B, would give you the log of AB. That's a nice little proof. What about the next one? Let's have a look here. If we're doing division of A by B, A is 10 to the log of A over 10 to the log of B. By your power or index laws, you subtract the powers. Okay, so here you're going to write A over B as 10 to the log of A over B. So that equals these two subtracted here, if you like. Okay, you're getting the idea. It's all linked with the powers because, remember, logs are powers. Okay, so A to the n, a number raised to the power n. Write the number as a power of 10, so it's 10 to the log of the number. And raise it to the n, you'll multiply the two together. Okay, but A to the n, of course, is 10 to the log of A to the n. So therefore, log of A to the n is n log A. It's proving that because logs are powers, you're going to follow the power rules for them. Okay, let's have a look at some more problems now using the laws. Just remember, logs are powers. So if I'm adding up logs, it's the same as adding powers, which is the log of a product. Fairly straightforward. Log of one number minus log of the other. Why would I subtract powers? I would be doing a division. So it's a log of 3. Okay, remember over here, logs are powers and it all falls into place. Log of 5, take 1. Hang on, well I can't mix numbers with logs, so can I write 1 as a log of something? Well, if I want 1 to be a log, it's got to be a power. So it's a power of 10. 1 is the log of 10, or the power you raise 10 to. The 1 has to be a power of 10. Okay, so let's subtract them now. That subtracting powers, you'd be doing a division of the numbers. So it's log of a half. Do you get it? So there's a few down here. Just watch it. Remember the power or index laws. Power rules apply for logs because logs are powers. All right, pause it. You need to do all of these, I think, to keep the practice up. Okay, and I'll show you the answers now. All right, check them out. They were important to get those right, that particular set. Okay, let's move on, and we'll just have a look at a couple more and then we'll give you a rest because that's all we're doing with logs. Just remember, logs are powers. Use the laws of logarithms to simplify these. Oh, we're multiplying a log by a number. What does that mean? It means it's raised to a power. You only multiply powers together when you are raising to a power. So 3 log 2, remember this is a power, so why would you be multiplying it by 3? Well, you're raising the number to a power, 2 cubed. And then you can work it out. Log of 49, take log of 8, which is the log of a subtraction of powers, would mean you're dividing the numbers. And here, multiplying a power, remember log is a power, by a number there would mean you're raising it to a power. And 1 you can't mix, you've got to call that the log of 10 to the 1. Okay, because here we're trying to simplify an expression, we want to get them all in logs. Okay, so you can't work with a number in a log. Okay, so come down, I want you to have a look at these. So there are a couple particularly you want to watch. This one over here, this one. To simplify, you must write all the numbers in there as logs, and then you can combine them using the rules. Okay, now you need to do all of these. So pause the presentation and have a go, and I'll show you the answers. So there's our set of answers there. And just go back and check the method that we've been using. All right, nearly finished. We just have a look at a few more ideas here. Simplify without using a calculator. Now people find this confusing. Log 8 divided by log 4. Now this is dividing logs, not numbers, so you can't subtract them. Just watch this now, we're dividing logs. Okay, and there's no rule for dividing powers. So what are we going to do? We're going to have to break it down. Log of 8 is the log of 2 cubed. Log of 4 is the log of 2 squared. And then we can say, well, if you're finding the log of a power of a number, it's 3 times the log of 2. And here it's 2 times the log of 2. And you cancel out the log of 2 and get 3 over 2. Okay, so it's very important that you see that if you're dividing logs, you won't be subtracting powers. Logs are powers, and there's no rule for division of powers as such. So you've got to go and do a simplification. All right. You can check your answers with the calculator, but it's very important to see when you're dividing logs, there is no rule. You've got to break the logs down and cancel out a common factor. All right, pause it and have a go. Remember, logs are powers. Right, let's have a look at the answers now. There they are. And are you getting your head around this? I hope so. All right, just remember, logs are powers. Here's the dude over here, still there with you all the time there, mate. So here, log of 1/9, can we show that it equals this? Well, to show that, so you've got to be careful. Log of 1/9, let's first of all write 1/9 as a power. It's a power of 3, or 1 over 3 squared, isn't it? Hope you know those power rules, because logs are powers and they're overlapping all the time. So therefore it's minus 2 by the log of a number, because if you have a number raised to a power, then you're going to, if you make that number a power of 10, you have to multiply the powers together. Remember, that's what we're doing. A log of 3 is the power of 10 to get 3. It's a power. Log of 500. You could call that 1,000 over 2, which therefore of 2 numbers divided, the log of that is the log of the top one minus log of the bottom one. And the log of 1,000 is 3, because 1,000 is 10 to the 3. Remember, the log of a number is a power of 10 here, minus log 2. And so we've proven it. So there's some tricky little things you can do with these logs now. We found them for solving exponential equations, but there's a whole new world now of working with them. So try these problems. I'll show you the solutions now. Oops, haven't got those there. Oh, you're going to have to check that out. Okay, so let's have a look at the next one. Write the following logarithms, logarithmic equations in base 10. So can we write these as equations? Okay, y equals a squared b. Well, we'll take the log of both sides. So log of y equals the log of a squared b. Log of y equals, therefore, log a squared plus log b. Multiplying 2 numbers, you add their powers. And that becomes 2 log a plus log b. So it's just using the rules to break down expressions, taking the log of both sides. Here, log of a quotient is the subtraction of the logs. 2 numbers divided, you subtract their powers, or their logs. And then the same thing here with b cubed, you're raising a power here to another power, 3 log b. When do you multiply powers together? When the number is raised to a power. This is a bit more complicated. Log of p is the log of this. So it's a log of the top line minus a log of root n. And then looking that up on the calculator, and root n is n to the half. So log of n to the half is a half log n. Do you get it? Logs are powers. So come down and let's have a look at question 2. And taking the log of both sides and just trying to simplify them. Just getting your head around the meaning of a log. Okay, so let's have a look at the answers there. I've got the answers to that one. Sorry about the other ones there. You'll have to just go back, maybe have a look at the book with that one and make sure. All right, check them off and let's move on. Nearly finishing now, and let's have a look at simplifying some equations which already have logs, going forwards and backwards and forwards. And so just keep your head around logs of powers and which way we're going. So log of g is x plus 2. Therefore, the log of g is x plus 2. That must be a power. Remember, logs are powers. We're saying the log of g is x plus 2. Therefore, g is 10 to the x plus 2. Or we can break that down, 10 to the x times 10 to the 2. If you add your powers, you're multiplying numbers together. So it's 100 by 10 to the x, because here 10 squared is 100. Log of m is approximately 1.301. Why is it approximately, that sign there? Because this has been rounded off to 3 decimal places. So if log of m is this thing here is the log, it must be a power of 10. So you can say m is 10 to the 1.301 take x. Okay, and therefore that means it's 10 to the 1.301 divided by 10 to the x. There's the power rule there. You're subtracting powers, therefore you're doing division of the numbers. And then you can look it up on the calculator. 10 to the 1.3010 is 20 over 10 to the x. You can only put approximately because no one says exactly what that 1.301 is. It could go on for further, so it's approximately 20. Okay, have a look at these. Can you remember now? If you say the log of something is x take 1, then that is the power of 10. All right, have a go. So maybe just do alternate parts there. I'll show you the answers. Question 6 there. Okay. Let's go down and the last little bit before an interesting little part. Write the following equations without logarithms. Okay. So here we have an equation. This is log b and 2 log c multiplying a power. Remember, logs are powers. Multiplying a power by 2 is what you would do if you're raising the number to a power, log c squared. So now we're adding powers. So that's going to be done when you multiply the numbers together. Log of b c squared. We've done it. Let's take the other one now. You can see we can't use this until we make it all in logland. We've got rules combining logs, but not logs and numbers directly. So let's have a look at the first part. 3 log a, logs are powers. So we're multiplying a power by a number. It's the log of a cubed raised to a power. And what is 1? I want to write it as a log so I can combine logs. So what is 1 the log of? What is 1 the power of 10 of? 10. 10 to the 1. Okay, so writing everything as powers of 10. I'm subtracting logs, so I'm subtracting powers. So I must be doing a division. What we're doing now is remembering that if we do a division, then we subtract the powers. When we talk about logs, we're talking about just the powers there. Okay, do you get it? I hope you do by now. Okay, write the following equations without logs. So trying to get rid of all the logs in here. Okay, probably need to do all of these to get your skill level up there. Well, I'll show you the answer now. Question 7. And see what you think. Okay, come down to the logarithmic function. And what we're going to do here is to say, well, we've been doing lots of rules with logs. What about treating it as a function in its own right? could you draw a graph of it and look at things like that? Remembering logs are powers. In this case, it's a power of 10. So you could say, let's try and graph it. Well, could we try and find over here neg1, neg2? It doesn't look like the graph exists there. What's the log of neg1? Can we plot that? No, because no matter what power you raise 10 to, you're always going to have a positive, aren't you? Even 10 to the negative power is 1 over 10 squared, which is 1 over 100. That's what we've got here. Okay, so it never goes in this region down here. There's no power of a positive base that would produce a negative number. So there's no log of a negative number. You can't raise 10 to any power to get a negative. So the graph only exists over here on this side of 0 for x greater than 0. And can you have the log of 0? Can you have an equals there? No, because no matter what power you raise 10 to, you can never come to nothing. You can't come to a negative or 0. So it's going to be an asymptote here. You can see what's happening with these negative powers. They're getting smaller and smaller negative numbers, so the y value is coming down here. But it's never going to be, as across here, it's never going to meet the x-axis. Okay, the y value here is just going to get smaller and smaller, but it's not going to equal the 0 there. Okay, so here, let's have a look at some of these and see if we can plot them. Okay, so we know x can't be 0, but as you come up here, where will it cross the x-axis? Okay, well, it crosses the x-axis when y is 0, and what value would that be? What x value, or what number, has 0 as its power, or its log? That's 1, isn't it? The log of 1 is 0. The y value, the power you raise the base to get 1 is 0. So this is going to be the point 0, 1 for any log graph. And then 10 to the half and so on as you get bigger powers here, x values, so your log is going to go up. Okay, so we're looking at x as various values, root 10, 10, 100, and so it's gradually going to go up. There's no asymptote. It just gradually creeps up, excuse me, slowly. So you can find the log of any number greater than 0, and that's the graph, what the graph is going to look like. Okay, so let's go down and finish off now, and got a question for you. Does this make sense, I wonder? Can we use other bases? What if you used other bases? Remember, logs are just powers. Could you talk about raising other bases, not base 10, to a power? We'd usually use base 10 because it's the base of our decimal system. Dec in decimal and decade means 10, doesn't stand for 10 from the Latin. But could we do this? Could we say log to the base 3 of 9? What power would you raise 3 to get 9? Is that doable? Yeah, 9 is 3 squared. So you could say the log to the base 3 of 9 is 2. And I'll put in brackets here because 9 is 3 squared. What about log to the base 2 of 8? What power do you raise 2 to get 8? Well, that's 3. All right, so if we say logs are powers of the base, then we could maybe do different bases. What about log to the base 4 of 64? Do you want to write it out in full? That's log to the base 4 of 4 cubed. So what is that? Oh, it's written as a power of 4, and the log of a number is the power there of the base. Hey, it seems to be working. Log to the base 5 of 125. What power would you raise 5 to get 125? It would be 3, because 5 cubed is 125. So look what I've done down here to you. This is expanding it. The log of a number is the power of the base, not necessarily 10. Wow, that just blew out, didn't it? We could do it in any basis. And maybe if you're on with mathematics, you'll study that a bit further later on. It's not in this course, just the idea here. So I've got some little problems you might have a go at with this new expanded definition, where you can talk about the log of a number to different bases. So come down and let's do a couple of exercises just to finish off. So write an equivalent exponential equation for this. If I say log to the base 10 of 100 equals 2, what does that mean to you? Hang on, logs are powers. So what that means is the log of 100 is 2. So 100 equals the base raised to the log. So that's what we wanted you to write out here. And similarly, something like this. If the log to the base 2 of 8 is 3, the log is 3, so that's got to be a power of the base to get that number 8. So please note that definition. Logs are powers, the power required of the base to get the number. Okay, so when you say the log is that, that's got to be the power. Do you get it? Have a go and see what you think. I'll show you the answers now. All right, so there you go. One last question for you. Here you are, just to wrap this all up, and you've got a good background now in logarithms, I hope. So just remember, logs are powers, even if you're not using base 10. What's the log to the base 2 of 16? Well, hang on, what is 16 as a power of 2? Because remember, to get the log, it's the power you raise the base to. So let's find the power of base 2, get 16, it's 4. So by definition now, the power you raise 2 to get 16 is 4, so that's the log. Log to the base 5 of 0.2. Well, let's work on 0.2. 0.2 is 1/5, or 5 to the neg 1. So can you do it? What's the log of 5 to the neg 1? To the base 5? It's the power you raise 5 to get 5 to the neg 1. Well, the little dude's already written as a power of 5. So the answer is neg 1. Log of a number is the power of the base. Logs are powers. So what about this creature here, base 10, of the 5th root of 100? Well, 100 is 10 squared. And 5th root is 1/5. So this is 10 to the 2/5. Now we can answer the question. Because remember, the log of a number is the power required of the base to get the number. So that's base 10. And we've been able to write it as a power of 10. So it's 2/5. Do you get it? What about this one? Base 2. So I think we'll go off hunting to make this a power of 2. 1 over root 2 is 1 over 2 to the half, and 1 overs are neg power. So it's log to the base 2 of 2 to the neg a half. And this is asking here, log to the base 2, it's asking what is the power of 2? Oh, we've been able to write it as a power of 2. So the answer is that power of 2, which is neg a half. All right, some final problems there for you. You might try all of those. It's just the same idea. Get the base and try to write that number as a power of it. And if you have, you've gotten the log. Logs are powers. Okay, have a go and I'll show you the final answers now. There we have them. All right, how did you go? Hope everything went quite well. And I'm going to catch you later on as we use these in a bit of modelling later on. So we've been gearing up with exponential functions to do some mathematical models. But for the moment, cheers for now.